potential for solar. There's presently, I think, about 1,000 megawatts of solar installed. Wind potential is 50,000 megawatts plus. Present about 800 megawatts installed. Hydro 50,000 megawatts plus. Present about 7,000 megawatts installed. And I think the current installed capacity is 30,000 megawatts. Projected demand 2025 is 49,000. Sorry, I can't see. And the question is, what's the share of renewables? Then this is a very important slide. This is, you need to understand this. There's low appreciation of renewable energy. And I can speculate on the problems, the factors, and I think you run across this in Sri Lanka, India, and so on. You ran across this in the West. I used to work in California in the 1980s. They were laughing at renewable energy like wind and solar, you see, because they never had any idea of how this would be going. But there's lack of vision and long-term strategy. Technocrats are comfortable with conventional, they have a conventional mindset, and they have experience with very large plants. There's governance issues, and there's bottlenecks, and there's bureaucratic impediments, and they're not technical issues really, and then they're not comfortable with unregulated sources of power, not recognize the impact of wind and solar, and not keeping up with rapid changes taking place in the electric supply industry. Then there's inability to introduce innovative business models. That is very, very important, because you have a multitude of business activity related to distributed generation, and you need investment coming in from private sector, and you need to create some business models that will attract the investment. The lack of excitement about the new technologies coming in. I'm excited. I'm like a kid. I cannot comprehend what's going on. I'm so excited, but this is lacking in the technocracy today. It's unfortunate. And then, of course, there's power politics, where, and I don't blame the coal industry. A coal mining company wants to promote coal. That's their business. They would go in, they would combine with a big EPC contractor, they would arrange for financing, and they would come to a government in a developing country and say, listen, you have demand for power, we can do this project for you, we can arrange a loan, and we can do this. And the regimes generally say, oh yeah, okay, we will have that. So it throws out the whole strategic thinking of trying to unroll renewables when you suddenly have a big block of coal coming in, and that suppresses the renewable energy development downstream, which is a bad thing. And then I will go into renewable energy examples. One is a hybridization of existing plant, a wind plant in Sindh, then further expansion of wind power in Sindh with solar and battery storage, harnessing large-scale wind and solar in Balochistan. Unfortunately, there's security issues, but we're looking long-term here. Then networked regional grids, wind, solar, hydro, and hybrids, net-metered solar, PV with storage. These are for industrial, commercial, and residential applications. And in here, there's this demand charge regime. You would commit to not consuming, your maximum consumption will be limited at so many kilowatts, say 10, 15, 100 kilowatts. And if you exceed that, you will pay a penalty. And you're below that, and if you are going to exceed, you have storage that you utilize so that you stay below that. And then there's going to be time of day tariff as well. So you will utilize smart sensors, meters, will make sure that you only consume when the tariff is low, and otherwise you will be using your own energy for electricity. Now, it's important in this regime that you do resource mapping. I mean, the World Bank have done a lot of this work in the World Bank East Map for Pakistan with wind and solar. And then you need the geographic information systems, because you need to lay out in the country where all these resources are and what other factors are going to impede development. If it's archaeological, population, or some other sensitive security matters, Pakistan has, in the north especially, there is certain areas where you can do wind farms, but then the Pakistan military have sensitive security installations and so on. So a GIS system will indicate that. Then the other is the training of professional staff, a professional cadre for renewable energy technologies. The demand is going to be huge because you have a distributed generation. Skilled jobs are spread throughout the country, and that's a very good thing for economic development. Okay, so now hybridization of existing wind plants in Sindh. So the idea is that you would harness solar within the existing wind plant, because I already have the substation infrastructure, and there is no technical reason that will stop me from putting some solar and battery storage and evacuating it through the existing substation. If it's even rated for 50 megawatt, I can still evacuate. Now, there's no technical reason for doing that. If I exceed, I store. And then we're coming to a regime where we have to commit long-term forecasting. We've got to commit to within 20% of what the plant output is. And if you exceed that, you may pay penalties. So the batteries come in and it can help out there too. Now, this will not be allowed. Currently, there's resistance from the bureaucracy because, oh, you are licensed for wind, you're not licensed for solar. But that's nonsense because you're power short. You're short of water, and you need water. So then the planner would say, look, we want you to maximize the resource here. So harness solar and evacuate to the existing substation. Otherwise, you could build another solar plant. There's a lot of land, especially in Jampir area, which is also, rich in solar. And remember that all this comes in because solar prices are coming down. And now, I mean, the solar resource in Sindh is not as good as in Balochistan, but because of the solar PV prices are coming down, it makes it economic. Then one of the things in terms of determining how much solar and how much battery to build within an existing wind farm, you will have to do a lot of analysis because in the end you need to optimize on the amount of solar peak capacity and the amount of storage. So the regulator has to be innovative here. Okay, this is a nice graphic to show you a wind-solar hybrid. Okay, now the other idea is to expansion. It's not an idea, it's pretty obvious that there's tremendous wind resources in Sindh, and you can expand along the Garo corridor in the northeast direction. And today you have large-sized wind turbines, 3 megawatt plus capacity, 120 meter hub height or greater, and then 140 meter rotor diameter. What this is doing is you're going higher because the power from wind is proportional to the cube of the wind speed, and the higher you go, the greater the wind speed. So there's a lot of incentive to go higher. And these modern plants, I mean, the scientists from Mingyang explained they can, in Jampir, can today yield net capacity factor about 40%. Then I think there'll be solar and battery storage and hybrid arrangement, and also expanding in a southwest direction towards the ocean. You will have all the tidal land, extensive amount of tidal land. It's challenging from a civil engineering point of view, and I think the developer should get a favorable tariff because it's so close to this huge city of Karachi of 25 million, 20 million plus population with a huge appetite for electricity. And of course, a decade ahead, you will see offshore wind coming in Pakistan as well. Okay, harnessing large-scale wind and solar in Balochistan. I mean, Balochistan is a renewable energy, wind, solar, gold mine. And unfortunately, the security issues are there, and also the distance, resource distance from major, power consuming like Karachi. But the distance from Gwadar to Karachi, I believe, is about 600 kilometers. Okay. And so it justifies, if you harness a lot of energy, justifies building a high voltage transmission line. And in the southern case, you will need gas turbines, diesel for regulation of this huge resource that's intermittent, wind and solar. Okay, emerging renewable energy scenarios, network regional grids, wind, solar, hydro storage. Province of KP is resource rich for setting up hybrid regional grids. They have tremendous hydro, they got solar, limited wind on the ridge lines, and KP doesn't need any external energy sources. It's self-sufficient. In fact, I believe KP can export its electrical power. There should be export-import provisions with the national grid. Again, there's legal and regulatory mechanisms essential. Then the world of what I call prosumers, producer-consumers, net-metered solar PV with storage, industrial, commercial, and residential. Then the energy storage business models. People are running business models to buy power cheap and then store and use later. And then there's, this happens in the environment of demand charge and time of day tariff. Okay, and this is a typical smart grid in a prosumer environment. As I said, demand charge, time of day tariff, and producing, consuming, wheeling. A factory might want green power, so they'll wheel it to the factory. And so you have, and a lot of these, if the grid is stressed, it can drop out the commercial building or the household or the factory, because the factory would have its own power source to manage until the grid is back to normal again. And there will be, because of advanced forecasting, they will know what is going on. Okay, residential prosumers, again, households. These are fancy graphics from modern countries, but it's in developed countries, but it should apply for Pakistan in affluent households, commercial facilities, and so on. And the next slide is, okay, and this 60% of Pakistan population is rural, and how much of them are off-grid? I mean, this is an ideal application to have solar PV with battery storage, and rather than push from a centralized fossil fuel plant all the way to rural areas, and that's wasteful and also may create a huge carbon footprint. Okay, transiting towards renewable energy prominence. This is a long, painful slide. I mean, you need resource assessments. You need to know, you need a trained technical cadre. You need policies for accelerating renewable energy. You need advanced programs for system simulation. You need to educate the technocrats about these things. And then if you're going to add, in your planning, if you demand firm capacity, if you're going to add thermal power plant, you really need to be careful, because you're doing that in the time when wind and solar price and battery storage is dropping, and you don't want that solar plant, that fossil fuel plant, suppressing the harnessing of low-cost wind and solar, and that's a very, very important factor. So you need to have stringent analysis to justify developing that fossil fuel plant. Okay. Oh, jeez. Thank you very much. That's it. This, you need to fix this. You need some oil. It needs lubrication.
Some solar battery.
Thank you, Engineer Mayura. You have raised some very important points. IEEE is looking into most of them, but we assure you that the rest of them will also be taken care of, and we look into each one of them and all of them. Luckily, we have got our President, IEEE, Dr. Rana Abdul Jabbar Khan, GM NTDC, ex-CEO ISCO, ex-CEO FESCO, Chief Operating Officer of Qaid-e-Azam Solar Park, who is also the Chairman of Grid Code Committee in NTDC. He is here with us. He has listened to you. And Dr. Saab, inshallah, will take up all these things, whatever Engineer Mayura has pointed out here today. So now our next speaker is Engineer Hassaan Idrees, and his topic is variable renewable energy integration, today's model versus electric network of the future. Hassaan Idrees, please.
Hello. Hi, everyone. Thank you very much for being here today. It's a difficult experience when you're the one person standing between people and lunch, so I'll try to be short. All right. So thank you again for joining with us today. My name is Hassaan Idrees, and I'm from KE. It's one of the largest vertically integrated private power utilities in the world, and the only one of its kind in Pakistan. If you're a resident of Karachi, then I'm going to assume that you are familiar with KE. I would be presenting on what integration of variable renewable energy sources in the distribution grid means, and the challenges that it brings within our power networks. Could you scroll down, please? So to understand the power dynamics holistically, it is essential to take a look at the electric power grid of Pakistan. The major part of the system is deregulated, meaning that the generation, transmission, and distribution functions, they're operated by separate entities. And NEPRA is the federal power regulator. The hydroelectric power plants of the country are run by WAPDA, which is the Water and Power Development Authority. The generation companies, called GENCOs for short, operate thermal power plants. And independent power producers, or IPPs, they inject power into the grid independently. The transmission system, it's operated by NTDC, which is the National Transmission and Dispatch Company. It operates systems of 500 kilovolts and 220 kilovolts. There are 10 ex-WAPDA discos, which are distribution companies, and they serve rest of the Pakistan except Karachi. KE serves Karachi and its surrounding areas with its own generation, transmission, and distribution system. The distribution system of KE is such that the capacity of its 11 kV system is about 7,000 megavolt amperes, and it uses a network of 22,000 PMTs and substations and such. The area covered by KE spans more than 2,500 square miles, and we currently serve more than 20 million consumers, million people in Karachi and parts of Balochistan. So now that we've taken a look at what the present system is like, how does the future look like for us? According to the World Research Institute and MIT's Energy Institute, the utility and the grid of the future, they're expected to be much more dynamic, much more active, rapidly evolving, heterogeneous, and customer-centric. So what exactly does that mean? That means that the grid is going to be modernized, and if you can go to the next slide, please. It means that the grid as we know it today, it's going to be evolving much more than it is right now. It would continue to do so. The familiar large-scale centralized generation and long-distance transmission and distribution, it would be supplemented and in part offset by variable renewable energy. More data would be in the system, there would be more energy storage solutions, and much more dynamic and distributed elements would be there. Given their rooftop PV systems, power consumers of today, they would become power producers plus consumers of tomorrow, or prosumers for short, which you've heard from other speakers as well. Next slide, please. So how does the potential for wind and solar in Pakistan look like? You've already heard from the other two esteemed speakers. According to Amjad Awan, the CEO of the federal government's Alternative Energy Development Board, or AEDB, Pakistan has a range of major solar power projects in the pipeline currently, and they amount to more than 4,400 megawatts in potential power. Speaking locally for Karachi, the possibilities of wind are comparatively less as opposed to solar. At 50-meter height, Karachi has a wind power density of around 200 to 300 watts per square meter of the area, and wind speeds range from 5.4 to 6.2 meters per second. On an average, Karachi enjoys horizontal solar radiation levels of about 5.5 kilowatt hours per square meter per day. Next slide, please. So what's the current status of distributed generation in Pakistan? Solar energy, as you all know, it's gaining momentum in the country. More than 1 gigawatt of PV projects have been under supervision of the AEDB federally operated organization. You can see that from 2015 to 2016, the capacity of distributed generation, or DG, for PV installation, the installation, it doubled, more than doubled in Pakistan. So distributed generation has been operational in the country for quite some time now. According to NEPRA, as you can see on the table here, more than 100 licenses were granted as of June 2017, last year, and that accounted for 2.3 megawatts of PV capacity. You can safely expect this number to be much higher today because a year has passed and solar has been permeated much more rapidly since then. As of July 2018, consumers of KE have added a distributed generation capacity of 278 kilowatts. The current trends in the country showcase that about 100 to 150 rupees per watt cost for solar, and this of course numbers change, depends on the quality of PV modules, the battery backup and such. Storage costs make solar more expensive. Dry and deep cycle batteries, they are significantly costlier than lead acid ones. In the market, you can easily purchase a 1 kilowatt inverter for 25,000, even less if you're willing to compromise on quality. And a 1 kilowatt grid type PV system, it can cost you up to 100,000 rupees. Next slide, please. Right. So how do we translate to local regulations? According to the U.S. Power Systems Engineering Research Center, which is a consortium of research institutes and universities, the challenges of integrating high penetrations of renewable energy technologies into the grid, as well as they're less well recognized, partly because they require interdisciplinary research in such areas as power systems analysis, communications, and such. So these challenges, of course, result from needed changes to achieve federal and regulatory objectives for low-carbon energy systems. Locally, AEDB and NEPRA, they have established a DG code, rolled out net metering throughout all discos. So policies have been made by NEPRA, and in 2015 to initiate load flow studies and advanced planning. So right now, single-phase inverters, which meet the specs, they are accepted for 5 kilowatt solar DG. Processing of applications for net metering up to 10 kilowatt without any study has been going on, which includes a majority of our residential areas. Each DISCO, including KE, they have now established net metering facilitation cells. Also, every DISCO, including KE again, they've installed a PV plant as their headquarters to set an example and provide necessary training. Next slide, please. So the objective is to integrate wind and solar while maintaining grid stability and reliability. For this, we of course need advanced controls. The challenges are first seen when there is an intermittent supply of energy. As opposed to fossil fuel power plants, solar and wind produce energy when resources are available, which means they're both variable and uncertain. This makes power system planning tougher and makes for complicated risk management. Apart from VRE itself, aspects like intermittent energy storage, demand-responsive loads, RE standards, and greenhouse gas emission policies, they all make these systems problematic than traditional power systems. Forecasting, both for renewable sources and for the load, it's more challenging. Planning for transmission and distribution is more complex when there is little predictability with line loading and PMT loading, which is pole-mounted transformers. Interface between the grid and the variable energy resource, they need to be monitored and approved for equipment interconnection, including basic parameters for power quality like harmonics, voltage, frequency, and power factor. Then again, power electronic devices at high power ratings, they need to be controlled and regulated, like the ubiquitous inverters. Next slide, please. So, with high levels of variable energy resources, in increasing penetration of these technologies, more and more challenges are becoming, permanent in our grid. So, what is going on? There are increasing levels of two-way power flow. Daytime energy flow to the grid is high with solar, as you know, and at nighttime, consumer electronic applications, they hog energy from the grid. So this calls for changes in the utility planning as well. Smart grids, of course, in turn, they ask for more use of communication, controls, data, and information. In developed countries, other new technologies like electric vehicles, like distributed storage, like batteries, flexible loads, they make these energy profiles much more highly distributed and which are much more complex to be monitored and controlled. Next slide, please. So what other challenges exist and how can we solve them? Coordination of protection components is tricky with variable energy resources, and when there's a loss of high short circuit current, it may affect protection schemes. The solution is then to use synchronous condensers to compensate for lagging VARs, or which is the reactive power. And advanced protection schemes are again also needed. Unintentional islanding can occur, and this can happen with increased infiltration of renewable energy sources, and this happens when one or more distributed resources, it becomes isolated from rest of the system, and then it inadvertently continues to serve loads separately from the utility. For this, new AI or artificial intelligence options, they're being developed as methods to protect against unintentional islanding. For events like black starting or the ability to restore system from outages, solutions can exist in the shape of new system restoration methods that can potentially work on advanced neural networks and fuzzy logic. That's a lot more advanced than we are currently are in our present grid. New control architectures and management topologies, they can solve challenges related to distribution controls. So are there any other solutions which exist? Yes, of course. First of all, we need to utilize geographic diversity. That helps a lot. How, you ask? When you have localized power generation and consumption, you eliminate a lot of T&D losses. Utilizing flexible conventional generation, it also helps. That means knowing when to run baseload plants and when to run peak load plants. Increasing sharing among NTDC areas, for example, it can help if VRE is integrated at sub-transmission levels. And then again, expanding the transmission system can smoothen out the impact of variable generation. In events when there is excess VRE production, storage can be used, which could be pumped storage or lithium-ion battery backups, for example. Coordinating flexible loads is another possibility. It means an active demand response system, and it means where end-to-end end-user consumers can change their electricity usage from their normal consumption patterns. Next slide, please. Okay, increasing penetration of variable VRE, it brings never faced before challenges, and it brings never faced before challenges to the power system stability as well. First of all, transient and dynamic stability is one such issue. The loss of system inertia can reduce ability to respond to disturbances, for example, and for which ride-through capabilities are needed in inverters. Frequency and volt-var regulations are of major concern. As an example, IEEE 1547 guidelines and UL 1741 guidelines, they need to be followed for voltages and frequencies to stay within permissible limits. The solutions that cater to these challenges means using smart meters and advanced functionalities. It is best that inverters that mimic synchronous generator characteristics, they're used, and that they provide active power, reactive power, voltage, and frequency control, respectively. Next slide. So here's a look at what's going to happen when you migrate from a centrally controlled synchronous generator-based grid to a distributed inverter-based system. We would need smart inverters with advanced functionalities, for example, to maintain grid stability and improved optimization for millions of controllable devices in the grid. IoT is becoming rampant these days, and with continued evolving of grid, we would need these capabilities. Needless to say, heavy research is needed in areas like control theory, areas like advanced control and optimization algorithms, embedded controllers, linkages with advanced distribution management systems, and validation of concepts and deployment. Next slide. So, which brings us here. What does the future hold? Experts predict that the grid of tomorrow should be decentralized, digitalized, and decarbonized, more so than it is already today. In each of these areas, our efforts in processing and distributed generation within our system, implementing advanced metering infrastructure, and embracing renewable energy systems at our own workplace, they are a testament to the fact that KE wants to stay at the forefront, locally and globally, hopefully as well. Exciting things are happening right now. For example, in SARC Energy Center in Islamabad, they're working on a supergrid for Afghanistan, Pakistan, and India, and microgrid studies are also happening in our part of the world as well as elsewhere. So with this, I conclude my presentation. Thank you very much.
Thank you, Engineer Hassaan Idrees. Jafri sir, what do you think? Should we have question answer session first and then your comments later? We'll have a short question answer session, 4 or 5 questions. Otherwise, the engineers will be here to answer questions. During the lunch also, you can meet them. And Dr. Renjing Chow will be available at his stall as well. So, questions please. Volunteers? Yeah.
My name is Engineer Parvez Sadiq. It's for the K Electric. Can they give a simple answer? If you want to put in a 10 kilowatt unit photovoltaic and want to have net metering, what would be their costs? Because I've been told that simply the meter again is being charged at rupees 50,000. So we have to make it easier for our pro consumers to be able to put in alternate energy. So it's up to KAC to give this answer.
You can come here as well.
That's fine. Can everyone hear me? Great. So the answer is not very difficult. You can access KE's website. There are all the procedures over there for net metering. If you need more help, we have our net metering facilitation center in Karachi and our Elanda Road office, and you can visit us over there for more answers. The 10 kilowatt system, basically the answer is just that you need to have a sanctioned load of at least that much for that consumer load. If you do not have that, you need to have a new connection process first, and then you can have net metering facility for your consumer.
Any more questions? There's one. Also one.
Hello, my name is Aurangzeb. I work at Hydro China Daud Power Private Limited. I have a question for Dr. Chow. Dr. Chow, you might be aware that we have problem in the grid network, and we have been experiencing high voltages up to 150 kV in a 132 kV network. So do you have any provision for the high voltage right-through capability in your new design? Thank you.
Thank you. Currently not. Currently not. Yeah. Because the voltage from the generator side is 690 voltage and go through a small transformer up to 35 kV and then to a substation. Yeah, for that. Currently not, because according to IEEE standard and also safety regulation of China, we focus more lower levels from the generator sides. Yes, of course, if we improve the voltage from the generator side, and then we can, for example, to reduce the losses from the cable. But on the other hand, from the turbine itself, you have to consider loading, the size, and the cost, and also safety, emergency, something else. So currently not. But in the future, typically for offshore, I think it's a good solution. Yeah. Thank you.
Thank you, Dr. Chow. I think this capability of high voltage right through should be included in the electrical balance of plant.
Right.
Dr. Naseem Khan has
Right.
got one question.
It's from Dr. Chow. Are you planning to use lattice towers? And if we are going to use lattice towers, does it reduce the cost of tower as such?
It's a good question. As you know, I think several decades ago in Europe, yeah, some small turbine use a lattice tower and having good performance. But for the higher megawatt turbine, due to the top mass is higher, and the lattice tower is a good design. It's cheaper, but problem is the torsional, the loadings, and the stability of the structure. Because for lattice tower, we need numerous conjunction and the connector, and the bolt and welding together. So for the quality control, it might be an issue. So currently, typically for the higher height tower, lattice tower, the only issue is the stability and loading. Yes. So for our prototype or for the soft tower, we don't use the lattice tower. As instead, we stick to the hybrid tower, for example, concrete plus the steel tower as a solution.
Dr. Chow, would you recommend concrete tower or hybrid concrete steel tower for Pakistan?
Maybe later.
Because we have got the raw material here available,
Yeah.
cement, steel, everything.
Maybe later, because the hybrid tower is a good design for low wind speed, because with a higher hub height. Yes. So currently in Pakistan market, as I know, the wind speed is good because the mean wind speed is above 6 meters per second. So currently, using the standard steel tower, yeah, could be a good solution to achieve the lower cost. Yes, thank you.
The last question.
Thank you. My name is Asif, and my question is very simple and from K Electric, and it's for the awareness for the general public, because there are a lot of people here who come to different companies and asking this question, which is related with the solar hybrid systems. And now there are two parts, one on-grid and one off-grid and hybrid systems. So always they ask that the K Electric people, they have some charges. They charged on hybrid systems as well, or on off-grid as well, because yes, there are regulations on on-grid systems when you install on grid system with your own website, with registered vendors. But related with the off-grid and hybrid systems, so K Electric is also charging them as well in the hybrid and off-grid systems. So you just need to clarify it to the people here and aware them. So thank you so much.
Thank you for the question. As long as your connection is with the meter and you're supplying power back to KE grid, you need to go through the proper procedure of making sure that the meter and everything is, is through the proper channel. If your system is off-grid and it has no connection with KE whatsoever, then of course, it has nothing to do with the electricity that is provided to you by KE. So, for example, if your hybrid system is grid-tied, because hybrid is both backup with battery as well as tied with the grid, then it would need to be, and you need to make sure that the system goes through the net metering policy.
I think we can continue this discussion later on during the lunchtime. The speakers will be available even after that. So
Yeah,
I would now request Engineer Jaffrey for his comments on the session and on the topics we discussed today.
Ladies and gentlemen, thank you and Assalamu alaikum. Looking at the watch, I realized that we started more than half an hour late. So at this point in time, we are not really late. So therefore, I will take the liberty of speaking a little bit more than what I would have if I would have thought that we were late. Although the fact of the case is that everybody must be thinking of lunch, including myself, but let's be a little patient and no harm in waiting a little while for the sumptuous lunch that waits. When you travel by road between USA and Canada, after a little while, you find very large fields, and in those large fields, there are very many huge wind turbines. Now, for people who know the current political thoughts within the United States, they would know that they are not very happy with the Canadians for one reason or the other. So anything that is about Canada, they find something wrong with it. So I was traveling, going to Toronto from Windsor, and I saw those large, tall wind turbines. Knowing, of course, myself what it was, I asked my colleague, who was, according to my terms, a Native American. Of course, he was a redneck. I asked him, what is this? He said, look, they have all that money to waste. Such big fans have been installed to cool the agriculture, and that is how they beat us in the cost of agriculture, but waste so much electricity that is available to them through the hydroelectric potential. Now, I am saying this, I thought some of you might smile, but there is a situation that all these people who have plenty of oil and gas available have very little interest in what is called alternative sources of energy. I have here in this hall a very great friend, Professor Dr. Naseem Khan. And he and I are dreaming that one day in this country we'll call all the fossil fuel-based plants as alternative energy. And the main plants would be with the technology. A little glimpse of that you have seen today. And I was very, very, very happy to see my young friend here talking so knowledgeably on that subject. Now, I will leave aside various details that have already been spoken at great length and very well. But I would say a few words which is from my heart about the great change, tabdili, coming from K-Electric through this young gentleman. I'm sure it must be encouraged by top people, by our great young friend Hali Javed, that they are so keen about merging of the alternative energy sources with the fossil fuel-based power generation in Karachi, and that may be a big lesson, tradition to be followed by our big brother, represented by Rana Sahib, who happens to be fortunately here. You see, Pakistan resources in the alternative energy field are tremendous. And I will not bore you further because a lot has been talked about it. But the fact of the case is that if we have the will, in 10 to 15 years' time, more than 10 to 15% of our power generation can easily be on what is today called alternative energy source. And by that time, I am quite sure that there will be sufficient indigenous technology, sufficient indigenous manufacturing facility, and the acceptance by the powers in Islamabad that yes, this is also a field worth considering. And that will be the day when people like us may not really be there. Of course, Dr. Naseem Khan may be there. He is much younger and much more smart and healthier. But I'm sure there will be very many of us who are sitting here who will be able to see this situation coming. And finally, before closing, I would like to make a request specifically to K-Electric. We have the young friend here, and we have quite a young friend, Khalid Javed, who is very knowledgeable in the field of power generation, that make a small team from K-Electric, IEEE, and also there are a lot of investors in the city who have put up wind and solar plants around Karachi, Champir, Garo, etc., and see how can K-Electric encourage them, financially support them, technically support them, and buying power from them into the K-Electric system. You see, sorry, I'm digressing a little bit. My elder brother, late elder brother, was a ship's captain. And he told me that he has traveled all over the world as a captain of the ship. So whenever he goes to a new port or port, there is a specific sign which starts saying that now you are reaching that port. And he said that when I have reached Karachi, I see from a distance a big bubble of dust, fume, and gases. Nothing else. That is because of the atmosphere. Of course, these days Lahore is also having problems, but restricting only to Karachi, this pollution, some of it, if not all, must be coming from the power generation emissions. And please do not be unhappy about it. If I am wrong, I am ready to be corrected. But I am sure that once you have this wheeling or transfer of clean energy into the system in K Electric, apart from the long-term effect, which I don't have to explain, it has been all talked about, we will definitely contribute to a better atmosphere, environment, and that is what we owe to our coming generation. I thank IEEE for having organized this very effective seminar. Please keep it up and make it an annual effort and continue with a full day session next year, having more and more papers from Pakistan and abroad. Thank you very much.
Please stay at this side of the table. So I've requested Jafri Sharp to be on this side of the table. So we have to give souvenirs to the speakers. I'll call upon Engineer Hassaan Idrees to come first and receive his shield from Hassaan Idrees. I request Engineer Mayura Botejue to please come and receive his seat. Dr. Renjing Chow from Mingyang Smart Energy Group. Jafri Saab, you may please keep on standing there for a while. I would like to request Dr. Rana Abdul Jabbar Khan, President IEEE, to come to the stage and give away a souvenir to Session Chair, Engineer Jafri. So it's my pleasant duty now to invite you for lunch. The lunch is served. It's on both sides of the hall. Please feel convenient wherever you want to go. The next session would start in 45 minutes. So after the lunch, please come back and take your seats. We'll announce the session about 5-10 minutes before it starts. Thank you so much.